Hello dear students, welcome back again to study physics lesson. Dear students, the previous lesson we studied all of the example about this page. We studied this example about the buoyant force, question 1, question 2, we did all. Now we have some examples left, page 56, about section reviewing. Guys, those examples you can't solve by yourself. If there is any question, you can inform me then. For example, question 1 said, what is the difference between solid and fluid? The difference between them. What is the difference between solid and fluid? And then, because the question it's a two-part, and then what is the difference between gas and liquid? Guys, Baba. Solid first, we started even in chapter 2. Solid has a definite shape. So first thing about solid, we know that solid has a definite shape. Their shape is clear. Has a definite shape. So about solid, but fluid, while fluid does not. Fluid does not. So this is the answer about first part. The second part, what is the difference between gas and liquid? A gas, as we know that, Baba, we have only one difference, the most important difference between liquid and gas. Liquid has a definite volume, but gas do not. So the liquid has a definite volume, while gas does not. Liquid definite volume. The volume is definite, it's constant, stable, but gas do not. So solid, for the first part answer, solid has a definite shape, but fluid do not. And the second part, liquid has a different volume, but gas do not. The answer of question 1. Question 2. Students, you have this example. It said, which of the following object, you have 4 objects, A, B, C, D. Which one of them can float in a tube mercury? So you have a container. This container is filled by the mercury. This container is liquid. It's filled by the mercury liquid. So, and over the surface of the mercury, which of the object it can stay on the surface of the mercury? And students, the previous lesson we solve it. It depends on what the object can stay on the surface. It depends on the density. So the density of the mercury, which is equal to 13.6 times 10 power 3. The density of the liquid, 13.6 times 10 power 3. The density of the liquid, which is equal to 13.3 times 10 power 3. The density. Okay. So compare all of the density. We said we explained that the density of the object, it should be smaller than the density of the mercury to stay on the surface. So check one by one. Part A. The density of the solid gold is 19.3. So 19.3 is bigger than 13.3. So this part A, solid gold, cannot stay on the surface because it's heavy and it's much more greater than the density of the mercury. It cannot stay on the surface. So part A, it's wrong. Part B, part C, part D, all is the correct answer because all of them, their density, it's smaller than the density of the liquid. So all of them, part B, C, D, ice tube, iron, the 5 milliliters of water, so all of them can't stay on the surface because all of them, their density is small. Look, 0.9, it's smaller than 13. 7.8, smaller than 13. 1, small. So the answer B, C, D can't stay on the surface of the mercury because has a less density compared to the mercury, because all of them B, C, D has smaller density compared to the density of the mercury, 13.6, so they can't stay on the surface. Guys, Baba, question 3 and 4 you can solve by yourself as easy. If there's any question then inform me. in Telegram, or you can write in the comments if there's any question. Students, finally, new section 2, chapter 3. This section is about fluids pressure and temperature. So this page is only about pressure rules. What's the factor that can affect pressure? What is the relation between pressure and force and pressure and area? How does pressure change with the distance when the object goes under the water? So the purpose of this page, this section, we have to learn how to calculate the pressure exerted by the fluid, or how pressures change with the depth, or we have to explain, describe the fluids in terms of the temperature. So Baba, first we have a pressure in physics. What is the pressure in physics? We have this definition: pressure important, which is said the magnitude of the force on the surface per unit area. Guys, let me tell you in brief what is the meaning of pressure. We have this small area, any object, any small area, this is called area, for example, any space, the area. I would like to apply force on this area. Applying force on this area, it's called pressure, because pressure is equal to force over area. It means, Baba, applying force over this area, applying force over area, it's called to pressure. So the magnitude of the force on the surface area, applying any force to any place of the area, it's called pressure. Even in here it's written pressure is force per unit area. In general, it was pressure. So for example, look, we have this space. Another example, this area, I would like to apply a force on this area. For example, apply force on this area. So applying force on this space area is called pressure, because pressure, which is equal to what? Force over area. Okay, so now you understand pressure is equal to force over area. It means that you will apply to a bit force on a specific small area. The answer, you get pressure. Applying force, any specific pressure, any specific area, pressure, force over a small area, you can get pressure, because pressure equal to force over area. So this is a definition of the force. Force per unit area. Okay, what is the unit of the pressure? Baba, as we know that force unit is equal to Newton and the area unit is meter square. So the unit of the pressure equal to Newton per meter square. Or we have another name, it's called Pascal. So there's two units of pressure. Look, in here it's written all. The SI, International System Unit Pressure of the Pascal, which is equal to Newton per meter square. So there's two units, Newton over per meter square and Pascal, both it's right. Guys, according to this rule in physics, just understand the physics, you can understand the definition, the factors, all. What does pressure depends on? So according to this rule, this P is pressure and F it's force A area. This pressure depends on what? By the rule you can know, because pressure is equal to force over area. It means that pressure depends on force and area, because only you have force over area. So of course pressures depend on the force over area. So now we understand the definition, what is pressure, the rule, the unit, or even the factor too. One thing that's left, we have a relation between force and area, and pressure with force, pressure with how they can change by each other. Baba, look, force which is equal to force over area. Pressure, pressure is equal to force over area. How pressures can change with force, or how pressures can change with area? Relation pressure with force, it's directly proportional. It means that If we have a large force, we get a large pressure. If we have a small force, we get a small pressure. But relation between pressure with area inversely proportional. If we have a large pressure, or another meaning, let me tell another meaning. If we have a small area, we get a large pressure. So pressure with force, directly proportional. Both of them increase in the same time. If we have more pressure, we get more force. But if we have more pressure, or for example, if we have small area, we get large pressure. So pressure with area inversely proportional. Inversely proportional, it means one of them increase, the other decrease. But directly proportional, both of them is increase in the same time. Okay. Guys, look at this picture. This person is under the water, so they are wearing this clothes. Why? Because the person is under the water. There's a lot of pressure on this person. That's why they have to wear some heavy clothes to avoid themselves from the lot of pressure on it. Guys, this table, the pressure in different position, just for understanding, not that much important to memorize it. Baba, we have another topic. It's called Pascal's principle. Pascal's principle. It said pressure is applied to a fluid in a closed container is transmitted equally to every point of the fluid and to the walls of the container. You will understand this well, but let me explain this picture. You can understand all, because Pascal's principles you have to apply on this picture, this machine, this device. Baba, look with me step by step. This this picture, it's called hydraulic lift. This device is used now when the car is not working. When the car is not working, you wanted to fix it. The persons, how can to fix these cars? They have this machine, this device. The cars on these machines is used for what? This machine is used to lift these cars or move these cars up. So this is called hydraulic lift. And the process is called Pascal's principle. Let me explain what's Pascal's principle and how is the process. What is the principle? Baba, look. First, we have two sides. Look, area number 1, area number 2. Each area it's called piston. So area number 1 it's called first area, or it's called small piston. Area number 2 it's called second piston. And look, the small piston, by the name, look, small piston. It means that the first piston, the area, it's smaller than the second piston. Look, this piston it's smaller than that one. So there's a difference between them by the size of the area. Their size totally different. The first area, look, their size it's smaller than that one. So first piston and smaller than that one. Baba. And the first piston, in this piston we have to apply force. But in the second piston we cannot apply force. The second piston only, look, is the position of the car on the second piston. So the cars are staying on the second piston. The cars are staying on the second piston. Look, the position of the cars are staying on the second piston. But the first piston only, look, even by this direction you can't know, we have to apply only, you have to exert a force on the first piston. But the second piston is the position of the car. Okay, look, how is the process? I would like to apply force on this piston. Force on this piston. Baba, look, compare, as we said, this area, the area of these two pistons is different. So this area, it's more than that area. Guys, now we studied, Baba, the relation between area and pressure inversely proportional. So look, this area compared with this area, it's small. So this area, it's small area. So at the end, if we have a small area, at the end we get a large pressure, right? We said the relation between area and pressure inversely proportional. So to apply the force, to apply the force on this first piston, because the area is small, we can get a large pressure because the relation between area and pressure inversely proportional. There is small piston, we get large pressure. So now in here we are producing a large pressure because we have a small area. This large pressure inside the container is transmit equally. The large pressure now we get transmit equally at every point until they get to the second piston. So Baba, as we said now in here, according to the first piston, we get a large pressure. So this large pressure, even inside the container walls, transmit equally until they get to the second piston. Because the first pressure that we get, it was a large pressure, and until they get the second piston, still it's large pressure. So inside the container, no pressure lost. Still at every point, in this point, in this point, in this, still it's large pressure. So till the large pressures get to the second piston, still it's large pressure. So what that means? The pressure in the first piston, which is equal to the pressure in the second piston. So both pressure on different pistons are equal. So the pressure that we get in the first piston, which is smaller than, the pressure that we get in the first piston, because the area is small, we get a large pressure. So this large pressure is transmit to get the second piston. So Baba, now in here, look, in here we have a large pressure, right? This large pressure, because we have a large pressure, the large pressure can exert a large pressure on this piston, so that's why it can affect it, because we have a large pressure, that's why this cars can't go moves up. We can lift the cars easily because in here we have a large pressure. So this is the process. It's called Pascal principle. Let me repeat again. Look. Be with me, Baba. Look, Baba. In here, because we will apply a pressure on this small area. We have small area. If we have small area, we get a large pressure. So now in here we produce a large pressure. So this large pressure will be transmit equally till they'll get to the second piston. So inside the container, no losing pressure at every point. At each point, we have a equal pressure. Still it's large pressure without losing any value. So till it's become here, till the large pressures become here. So we say the pressure number 1 in here, which is equal to pressure number 2. So both are large pressure. So in here, because we have a large pressure, we have more pressure. Large pressure can exert a pressure on this large piston. So this large pistons make the cars to lift to goes up. So this process called Pascal's principle. Guys, in here all it's written. A small force F1 applied to a small piston. Small force. We have a force applied to a small piston. It's cause what? Pressure increase. And we get a large pressure. Now we said all. According to the Pascal's law. Look. Okay. This increase in pressure is transmit to a larger piston. And now we said this pressure is transmit to the large piston, to the second piston here. Area number 2. And the fluid exert force. The fluid exert force, because in here, look at this force, this pressures exert a force to the second piston on this piston. So this is called in general Pascal's principle. Again, by Barrett. Pressure applied to a fluid in closed container transmit equally. We said the pressure inside the container at every point equal till they get to the second piston, equal to every point to the walls of the container. That the pressure, Baba, look, the pressure that we get in here, we get a large pressure, transmit equally without losing any pressure. So at every point, still we have a large pressure until they'll get to the second piston. So this process is called Pascal's principle. So in general, Pascal's principle transmits a pressure from the first piston to the second piston without losing any energy, any value of the pressure. Because you have a small area, we get a large pressure. This large pressure transmit inside the container at every point. At every point, still you have a large pressure without losing any pressure. The pressure comes, it's large pressure to become until they get to the second piston. So in here, because you have a large pressure can exert a large pressure on these pistons. That's why they can move the cars to goes up, lifting the car, because you have a large pressure. Okay, guys, this is in general, even it's written all here, so the Pascal's principle. We have a rule relation between pressure and force to solve some examples. Guys, as we said in here, look, as we said in here, in both sides of the piston we have same pressure. So pressure number 1 equal to pressure number 2, because both sides we said same pressure, right? Okay, pressure number 1, which is equal to pressure number 2. And we know that pressure is equal to what? Let me write in here, is better. Look, Baba. We said for both sides, pressure number 1 equal to pressure number 2. And we know that pressure is equal to what? Force over area. Because it's pressure number 2 is become force 1, area 1 equal to pressure number 2, again force over area, but because it's pressure number 2 we become force 2, area 2. So now we get this formula. Memorize this formula. This is the rule to find the area or force in each equation. So there is a relation between the force that you are applying on the first piston, the force on the second piston. Okay, guys, let me just only solve this example, and today's just this example. I'd like to solve this example now. Pressure problem. The small piston of the hydraulic lift has an area. It's written small piston. يعني it means the first area. Small piston, first area. Look. Small piston. This small piston, first area. Small piston, first area. The first area number 1, which is equal to 0.20. A car's weighting 1.20 times 10 power 4 sits on a rack mounted on the large piston. Even I can't erase the large piston. Even it's second force. How? All time we said the position of the car all time it's on the second piston, the position of the car. So second piston, يعني you have F2 A2. So this force now we have F2 or A2, of course F2, because it said car position. يعني this force, it's force number 2. And the large piston has an area. Large piston يعني area number 2. How large force must be applied? Applying force all time we said. When you have to apply the force on the first piston, in here, look, we apply the force. So يعني find force number 1. So look, Baba, we have all. We have area number 1, we have force number 2, we have area number 2. Go to find unknown force number 1. Easy the rule. We have this rule. Easy. What was the rule? Force 1 over area 1 equal to force number 2 over area number 2. So we have this simple rule, F1 over A1, which is equal to F2 over A2. Okay, I would like to find F1, but before that, multiply is better, easy. Multiply now. F1 times A2. F1 times A2 is become F1 A2 equal to F2 times A1 become F2 A1. Multiply F2 times A1, F2 A1, F1 A2. Now I would like to find what, Baba? Find F1. How I can find F1? Divide both sides by A2 by area 2. So this area to area 2 is going to be cancelled. Only F1 is left. Write F1, which is equal to where is the value of the force 2? Look, we have force 2. 1.20 times 10 power 4 times area number 1. We have a look, area number 1 0.20. Area number 1 0.20. And what about area number 2? Area number 2, area number 2, 0.90. Area number 2, 0.90. Finish now. Multiply by using calculator. So the answer is, look, this is the answer. It's become force number 1 is equal to 2.7 times 10 power 3 Newton. So this is the value of the force that we are exerting, that we can exert on the first piston. Guys, today is enough. Today we studied some pressures, Pascal's, pressures rules, and today is enough. I hope to get the benefit from these lessons. From the upcoming lesson, inshallah, we are still continue to study lesson by lessons physics grade 10. Thank you for watching my video. If there's any question, you can write down the comments. Thank you for all. Have a nice day.